Imagine for a moment you're watching a movie, and suddenly all the scenes start playing backward. Actors walk backward, water rises from sinks into faucets, and broken eggs magically reassemble themselves. Seems absurd, doesn't it? But here's what will blow your mind. The fundamental laws of physics don't forbid this from happening. So why does time only move forward? Why do we never see a broken glass reconstitute itself, or a person age in reverse? Welcome, cosmic explorers, to another journey through the frontiers of knowledge. Today, we're going to unravel one of existence's greatest mysteries, the arrow of time. We'll discover why the universe has a preferred temporal direction, how this connects with cosmic expansion and entropy, and I'll tell you about a fascinating scientific hypothesis that there might be universes where time literally runs backward. Prepare for a trip that will forever change how you perceive every passing second. And before we begin our exploration, I want to remind you that we are on an incredible journey toward 1,000 cosmic explorers. Each of you is part of this crew that is discovering the universe's secrets together. Let's start with a question that might seem obvious but actually hides one of physics' deepest inquiries. What exactly is time? For us humans, time is this constant sensation that things happen in sequence. First, you wake up, then you have coffee, then you leave the house. But for physics, time is far more mysterious. Albert Einstein showed us that time isn't absolute as we once thought. It can pass slower or faster depending on the speed you're moving or the intensity of gravity around you. Imagine two twin brothers, one stays on Earth, and the other travels through space at a speed close to that of light. When the traveler returns, he will have aged less than his brother, who remained on Earth. Time literally passed slower for him. But even with this temporal flexibility, something remains constant: the direction of time. We never see the traveling brother get older than the one who stayed on Earth. Time may pass slower, but it never goes backward. This is what physicists call the arrow of time, or temporal asymmetry. Now, here's where things get truly intriguing. If you look at the fundamental equations of physics, most of them are completely symmetric with respect to time. This means that, mathematically, they work equally well whether time is moving forward or backward. It's as if the universe were a movie that could be played in any direction. Think of one billiard ball hitting another. If you film that collision and play the film backward, it will still appear physically possible. The laws of mechanics cannot distinguish which direction is the correct one. So, if the fundamental laws are symmetric, where does this arrow of time that we experience come from? The answer lies in one of the most important and yet most misunderstood laws of physics, the second law of thermodynamics. This law states that the entropy of an isolated system always increases with time. But what the heck is entropy? Imagine your room. When it's tidy, everything has a specific place. Books on the shelf, clothes in the closet, shoes organized. This is a state of low entropy, high organization. Now, as days pass, without you tidying anything, things start to spread out. Books end up on the table, clothes on the floor, shoes scattered. This is a state of high entropy, low organization. Entropy is, fundamentally, a measure of how many different ways you can arrange things while maintaining the same general appearance. A messy room has many more possible arrangements than a tidy room. And here's the crucial point. It's statistically much more likely for things to evolve from an organized state to a disorganized one than the other way around. That's why you never see a cooked egg uncook itself or a broken glass reconstitute. It's not that it's impossible by the laws of physics. It's that it's so improbable that it never happens in practice. The molecules of the cooked egg would have to rearrange themselves in precisely the right way. And the chances of that happening are less than you winning the lottery every day for the rest of your life. But hold on a minute. If entropy always increases, how did the universe start in a state of low entropy? After all, for entropy to increase, it must have started low at some point. And here we arrive at one of the deepest questions in modern cosmology. About 13.8 billion years ago, our universe began in an extremely organized and uniform state that we call the Big Bang. All matter and energy were concentrated in an incredibly small and hot region. This was a state of very low entropy. Since then, the universe has been expanding and becoming increasingly disorganized, with entropy constantly increasing. The expansion of the universe is intimately connected with the arrow of time. As space expands, matter spreads out, stars are born and die, and complex structures like galaxies and planets form and then break apart. This entire process is a gigantic entropy increasing machine operating on a cosmic scale. Think of it like a drop of ink falling into a glass of water. Initially, the ink is concentrated in a small spot, a state of low entropy. As time passes, it spreads throughout the water until all the water is uniformly colored, a state of high entropy. The universe is doing something similar, but on an unimaginable scale. Now, let's explore one of the most fascinating and controversial ideas in modern physics, the possibility of universes with inverted time. Some theoretical physicists have proposed that our universe may not be unique. In a hypothesis known as the specular universe, or two-time cosmology, there might exist another universe, connected to ours at the moment of the Big Bang, but where time flows in the opposite direction. Imagine two arrows of time emerging from the Big Bang in opposite directions. In our universe, time flows from the Big Bang to the future. In the specular universe, time would also flow forward from the perspective of its inhabitants, but that direction would be what we consider the past. To them, we would be the ones living backward. This isn't just philosophical speculation. Physicist Sean Carroll and other researchers have developed detailed mathematical models of how this could work. In these models, both universes would begin with low entropy at the Big Bang and evolve to states of high entropy, but in opposite temporal directions. If this were true, it would mean that there are conscious beings in the specular universe who experience time exactly as we do, with memories of the past and expectations of the future, but whose timeline points in the opposite direction to ours. They would see our universe as a place where time runs backward, just as we see theirs. But how could we detect such a universe? This is one of the major limitations of this hypothesis. By definition, we cannot communicate or interact directly with a universe where time flows in the opposite direction. It would be like trying to send a message to the past. However, some physicists suggest that there might be indirect evidence. Certain asymmetries observed in subatomic particles, or specific patterns in the cosmic microwave background radiation, could be signs of the existence of a specular universe. We are still very far from confirming or refuting these ideas, but the mere possibility is fascinating. Another intriguing aspect of the arrow of time involves quantum mechanics. In the quantum world, things behave very strangely. Particles can be in multiple places at the same time, and the very act of observing can change the outcome of an experiment. Some physicists have proposed that the arrow of time may emerge from quantum measurement processes. When you measure a quantum particle, it collapses from a state of multiple possibilities to a definite state. This process is irreversible and always happens in the same temporal direction. It may be that the macroscopic arrow of time we experience is the cumulative result of billions and billions of these microscopic quantum collapses. Let's pause to absorb what we've discovered so far. First, we learned that the fundamental laws of physics are time-symmetric, yet we experience a clear temporal direction. Second, we discovered that this arrow of time is connected with increasing entropy and the expansion of the universe. And third, we explored the fascinating possibility that there might be universes where time flows in the opposite direction. But there's another aspect of the arrow of time that is deeply personal to each of us: consciousness. Our subjective experience of time is unique. We remember the past, but not the future. We make decisions based on past information to influence future events. Is this psychological asymmetry of time intimately connected with the physical asymmetry? Many neuroscientists and physicists believe so. Our consciousness may have evolved to operate in harmony with the thermodynamic arrow of time. Remembering the past is useful because the past is fixed and determined. Trying to remember the future would be useless because the future is not yet determined and depends, in part, on our own actions. Imagine if our consciousness worked in reverse. If we remembered the future and knew nothing about the past, what would it be like to make decisions? What would it be like to live knowing exactly what will happen, but without understanding how we got to where we are? It would be a completely alien form of existence for us. Some philosophers and physicists have speculated that, if there are conscious beings in the specular universe we mentioned before, they may have a fundamentally different experience of consciousness than ours. They might remember what we consider the future and predict what we consider the past. To them, it would be perfectly natural and logical. Now, let's address a question that may be on many of your minds. If time has a preferred direction, does that mean free will is an illusion? If everything is evolving from low to high entropy in a deterministic way, do our choices really matter? This is one of the deepest questions in philosophy and physics, and there's no simple answer. On one hand, it's true that the universe as a whole is evolving in a statistically predictable way toward greater entropy. On the other hand, within that general framework, there is room for enormous complexity and unpredictability. Think about the weather. While we know that energy always flows from hot to cold regions, following the second law of thermodynamics, that doesn't mean we can predict exactly where it will rain next week. Complex systems, including human brains, can exhibit unpredictable behaviors even while operating within fundamental physical laws. Furthermore, quantum mechanics introduces a genuine element of randomness into the universe. Even if we had complete information about the current state of the universe, we still couldn't predict with absolute certainty what will happen in the future. There's always a fundamental margin of uncertainty. Let's now explore some of the most extreme implications of these ideas. If the universe truly began in a state of low entropy and is evolving toward high entropy, what happens in the end? Where is this arrow of time pointing? According to our current understanding, the universe is expanding and cooling. Eventually, all stars will burn out all their fuel and fade away. Black holes will evaporate through Hawking radiation. In the end, the universe may reach a state of maximum entropy called heat death, where there are no more energy gradients to sustain any process or complex structure. In this scenario, the arrow of time would reach its final destination. There would be no more change, no more evolution, no more history. Time, in a sense, would cease to have meaning. It would be the ultimate end of everything we know. But here's a fascinating twist. Some physicists have proposed that even in this state of heat death, extremely rare quantum fluctuations could occasionally create regions of low entropy. These regions could give rise to new local Big Bangs, creating bubble universes with their own arrows of time. If this is true, time may be cyclical on a much larger scale than we imagine. Our universe may be just one of infinite cycles of creation, evolution, and heat death. The arrow of time we experience may be just a segment of a much longer and more complex cosmic story. Another intriguing possibility comes from string theory and other theories of quantum gravity. These theories suggest that time itself may have emerged during the Big Bang. Before that, there may not have been an imperfor in the sense we understand it. Time and space may have been born together, simultaneously creating the arena where the arrow of time can operate. This raises profound questions about the nature of causality. If time had a beginning, what caused that beginning? How can we speak of cause and effect before time existed? These are questions that lie at the frontier between physics and philosophy, and we don't yet have definitive answers. Let's also consider how our understanding of the arrow of time might impact future technologies. If we can better understand the mechanisms that govern temporal direction, could we develop technologies that manipulate these processes? Some physicists have speculated about the possibility of creating time machines that harness extreme relativistic effects. While travel to the past seems impossible due to logical paradoxes, travel to the future is theoretically possible and has already been demonstrated on a small scale. Astronauts who spend months on the International Space Station return a few milliseconds younger than they would have been if they had stayed on Earth. There is also research into the possibility of creating local regions of low entropy, effectively reversing the arrow of time on a small scale. This could have applications in quantum computing, where the ability to undo quantum operations would be extremely valuable. But perhaps the most profound implication of understanding the arrow of time is philosophical. It forces us to confront fundamental questions about the nature of existence, consciousness, and our place in the cosmos. Are we merely passengers on a predetermined cosmic journey from low to high entropy, or are we active participants in the creation of the universe's history? The answer may be both. While we are subject to the fundamental laws of physics, our ability to process information, make decisions, and create complex structures makes us active agents in the universe's evolution. Every thought we have, every word we speak, every action we take contributes to the increase of cosmic entropy, but in unique and unpredictable ways. Recapping our cosmic journey today, we discovered that the arrow of time emerges from increasing entropy, is connected with the expansion of the universe, and may not be universal. We explored the fascinating possibility of specular universes where time flows in the opposite direction, and we saw how our consciousness is intimately connected with temporal direction. More importantly, we learned that time is not just a passive dimension where things happen. It is an active and dynamic feature of the universe that emerges from the fundamental laws of physics and cosmic history. Every moment we live is part of a cosmic narrative that began 13.8 billion years ago and will continue for trillions of years into the future. When you wake up tomorrow and feel time passing, remember that you are experiencing one of the most fundamental and mysterious features of the universe. You are surfing the arrow of time, carried by the cosmic current of increasing entropy, but also actively contributing to determining where that current will lead. This leads me to a final thought. If there really are specular universes, where conscious beings experience time in the opposite direction, they might, at this very moment, be remembering a future where humanity has completely unraveled the mysteries of time. To them, our current ignorance may just be a distant memory of a primitive past. What a humbling and at the same time inspiring perspective on our place in cosmic history. Cosmic explorers, now I want to hear from you. If you could travel to a universe where time runs backward, what do you think the experience would be like? Can you imagine what it would be like to have memories of the future and expectations of the past? Leave your reflections in the comments. I love reading each of your unique perspectives on these cosmic mysteries. And since we're talking about the future, what other mysteries of time and space would you like me to explore in future videos? Wormholes, temporal paradoxes, the quantum nature of time. Leave your suggestions in the comments. You are the ones who guide our journey of discovery. We are on an incredible journey toward 1,000 cosmic explorers, and each of you is essential to this crew that is unraveling the universe's secrets together. If this video expanded your horizons on the nature of time, join our community by clicking subscribe. Like this video if it made you see every passing second in a completely new way, and share it with someone else who is also fascinated by existence's deepest mysteries. In the next video, we will explore another phenomenon that challenges our intuition about time, how gravity can literally make time pass slower, and what that means for future space travelers. Until then, keep looking at the stars and questioning everything. The universe is full of mysteries waiting to be discovered, and you are the explorers who will unravel them.